This is Unit 8 review. We are going to identify the vertex, the axis of symmetry, and identify the range of the first four problems. So this is in vertex form, and our vertex is the opposite of our h value, vertex form, y equals a times the quantity x minus h squared plus k. So it's the opposite of our h value. So that would be 7. And we take k as is, that's our y. So our vertex is at 7, negative 6. Next we want our axis of symmetry. Well, we know that our axis of symmetry goes through our vertex, or our vertex is on the axis of symmetry. So that has to have the same x value. So it's x equals 7. Alright, we've got a vertex at 7, negative 6. So somewhere down here we've got our axis of symmetry at x equals 7. And we see that our a value is positive, so we know that our graph's going up. So our range is all real numbers, right? Everything that's above that line. So all real numbers that are greater than or equal to, what's this value? This was 7, negative 6. So everything greater than or equal to negative 6. Second problem is the same thing, same form. So our vertex is the opposite of this, so negative 1, and our k value as is, so negative 1, 5. That means that our axis of symmetry is x equals negative 1, and our range, because this is positive again, our leading coefficient, or our a value is positive, then our range, right? Imagine we've got a point now at negative 1, 5, somewhere up here. That's still positive, so we're going up. So we still want to be everything bigger than 5. So all real numbers greater than or equal to 5. 3. This is in a different form. This is standard form, so this isn't going to tell us our vertex, but we can find the part of it, our x value of our vertex. So first we're going to find our axis of symmetry, and that we use the equation x equals negative b over 2a. So x equals negative b over 2a. What's our b value is negative 2. So negative 2, and our a value is 1. So x equals, now from here I just count my negative factors. So I've got 2 negatives, so I know that this is going to be a positive. So positive 2 over positive 2, and that equals 1. So our axis of symmetry is x equals 1. So then to find our vertex, we want to say, well, we know that our x value of our vertex is 1 because it's on our axis of symmetry. So we're going to take our equation, y equals x squared minus 2x plus 8, and we're going to substitute that in for x. So our value of our axis of symmetry, which is 1, and we put it in for x, so 1 squared makes 1, negative 2 times 1 makes negative 2, and we're adding 8. So negative 1 minus 2 makes negative 1, plus 8 makes 7. So y is 7, so that would mean our vertex is 1, 7. And our range, then imagine our point here, our vertex is 1, 7. Up here, our leading coefficient is positive, so we know we're going up from here. So our range has got to be all real numbers that are greater than or equal to 7. Because we're bigger than 7 there. Everything bigger than that. 4, same thing, standard form. So our axis of symmetry, x equals negative b over 2a. Our b value is negative 6. Our a value this time is negative 1. So that's going to be, how many negatives do I have? I've got 3 negatives, so I know my answer is going to be negative. So this makes what? Negative 6 over 2. What's negative 6 divided by 2? That's going to be x equals negative 3. So our axis of symmetry is the vertical line at negative 3. So next, let's find our vertex. So y equals negative x squared minus 6x minus 13. And we're substituting in a negative 3. That's the value of our vertex. What's negative 3 squared makes 9, but we still have that negative out in front, so that's negative 9, because it's 9 times negative 1. Negative 6 and negative 3 make positive 18 minus 13. So negative 9 plus 18 makes positive 9. 9 minus 13 makes negative 4. So our vertex is negative 3, negative 4. Our range is going to be, imagine our graph, we're at negative 3, negative 4 down here, and our leading coefficient is negative, so we're going to go down, so we want everything below negative 4, so that's going to be all real numbers less than or equal to negative 4. Problem 5 is in a different form. This is in factored form, or roots form, or solutions form, because they're telling us the solutions. Why is it telling us the solutions? Because we can also say that y, if we're looking at just a xy, if we're looking at an xy, y values, x values, our coordinate plane, right? We could say all along this x-axis, our values of y are 0. So that means this equation can really be negative 2 times x minus, the quantity x minus 1 times the quantity x plus 3 is actually equal to 0 to find where we're crossing the x-axis. So because of our zero product property, we say x minus 1 equals 0 and x plus 3 equals 0 then. So x equals 1 and x equals negative 3. That's where our graph is going to cross, right out here at negative 3, 0, and over here at 1, 0. So we know we're crossing the x-axis there. So what does that tell us then? What I'd also like us to do is just be able to tell that by looking at the equation and say, hey, it says negative 1 here, so we know we're going to cross at the opposite of that. And it says positive 3 here, so we know we're going to cross at the opposite of that. So now what do we know is in between 2 points when we're talking about parabolas, quadratics here, right? What do we know? We know that there's an axis of symmetry, so we're going to have this vertical line going right down in between these 2 points. So we need to find what's the equation of that vertical line. Well, if we're at negative 3 over here and we're at 1 over here, if we added those together, that would make negative 2, and if we divide it by 2, we'd find the average, and that would be negative 1. So x equals negative 1 is that vertical line. So that tells us our x value of our vertex. So now to find the y value, we just take our equation and plug in a negative 1. So we'll write our equation, y equals negative 2 times the quantity x minus 1 times the quantity x plus 3, and we're subbing in our value of x, which was -1, and we're going to get out a y value here. So we got to work inside here, right? Order of operations, -1 minus 1 makes -2. So this is -2 times -2, and here -1 plus 3 makes 2. So now how many negative factors do we have? We've got 2 negative factors, so our y value is going to be +8. So that means that our vertex would be actually way up here at -1, 8. Also, this a value, right, is -2, so we should know that we're going down from here. And so our vertex, we got our vertex, right? Vertex, we labeled -1, 8. And our vertex, we wanted our axis of symmetry, which was AOS, is x equals -1, and the range is all of our y values, or all real numbers, that are less than or equal to 8, because we've got to be below that y value up there. Alright, same thing for this other equation. So let's do this one just a little bit faster. Let's still graph though. We'll still make a graph. So here's our x-axis, here's our y-axis, and we should be able to tell real quickly that we're going to cross at -5 out here, -5, 0, and out here at -1, 0. So -1, 0. The opposite of both of those, right? So what's in between there should be our axis of symmetry. Should be right here. How are we going to find that? It's going to be -5, right, plus -1 divided by 2. So -5 and -1 make -6. Divided by 2 would be x equals -3. So our axis of symmetry, AOS, is x equals -3. So now we want to find our vertex. So we're going to take our equation, y equals x plus 5, the quantity x plus 5, times the quantity x plus 1, and we're going to sub in our value of our vertex, or our value of our axis of symmetry, which is -3. It's our x value of our vertex. -3 plus 5 makes 2, and -3 plus 1 makes -2, and that's 2 negative factors, so y is -4. So our vertex is -3, -4, -3, -4, let's say down here somewhere. Our leading coefficient was, or our a value is positive, right? We're going up. So then our range is all real numbers that are greater than or equal to -4. Seven, graph these, identify the vertex, axis of symmetry, domain, range. So, there we go, we're in vertex form. So our vertex is -3, -6, -3, -6, right here. Let's label it. -3, -6. That's our vertex. There we go. Then, that means that we have an axis of symmetry at x equals -3. So we'll graph that and label that. AOS x equals -3. From here, we got to work our way out, so we'll take our equation. Y equals 3 times the quantity x plus 3 squared minus 6, and we're going to substitute in, oops, not a 3, we're going to substitute in, let's substitute in a -2, we're just working 1 unit to the right. So substitute in a -2, -2 plus 3 makes 1, 1 squared makes 1, 1 times 3 makes, let me write this out for you, 3, that makes 1. Following our order of operations, that's going to make 1 again. 3 times 1 makes 3, and 3 minus 6 is -3. So that means when x is -2, y is -3, that's our next point, -2, -3, right there. Because of the axis of symmetry, we know we have another point on the other side of the axis of symmetry, right there. And next, we'll plug in another point. What should we choose next? Let's go one more to the right, so that would be -2, -1. So we'll plug in a -1. -1 plus 3 makes 2. 2 squared makes 4. 3 times 4 makes 12, and 12 minus 6 makes 6. So we've got another point at -1, 6. That's 2 units on the right of the axis of symmetry, so we move 2 units to the left. Well, and I should make those more curved, but that's good enough. And there's our graph. Labeled our vertex, axis of symmetry. Oh, and we need our range. So our range, right, we're going to be above -6, so we're all real numbers that are greater than or equal to -6. 8, same thing. Vertex is at 2, 3, 2, 3. We can make our axis, oh, let's label it. 2, 3. Vertex. We also have an axis of symmetry then. It's x equals 2. X equals 2. That's our AOS. Now we need to plug in our numbers. So y equals -1/2 times x minus 2 squared plus 3. And the first number that I'm going to plug in is going to be a 3, because that's one number to the right, so we'll sub in a 3 here. 3 minus 2 makes 1, so this is -1/2 times 1 squared plus 3. 1 squared makes 1. -1/2 times 1 plus 3. -1/2 times 1 makes -1/2, and 3 minus 1/2 is 2.5, or 2 times 2 is 4, plus 1 is 5, or 5/2. Those are equivalent. So at 3, when we plug in a 3, we get out 5/2, or 2.5. So 3, 2.5, right there. We move to the other side of the axis of symmetry. That would be 1, 2.5. Next, what will we plug in? How about a 4? So next we'll substitute in a 4. -1/2 times 4 minus 2 is 2 squared plus 3. 2 squared makes 4. -1/2 times 4 plus 3. -1/2 times 4. Half of 4 is 2. Negative factor, so -2 plus 3. That makes 1. So that's 4, 1. And that means we'd be at 0, 1. Let's do one more. last, well, let's plug in a 5. So 5 minus 2 is 3. 3 squared, negative 1/2 times 3 squared plus 3. 3 squared makes 9. Negative 1/2 times 9 plus 3. Half of negative 1/2 of 9 would be negative 4.5. Plus 3 would be negative 1.5. That would be the same as negative 3/2. So 5, negative 1.5, and negative 1, negative 1.5. And that's enough. What didn't we do? Our range. Our range is everything below, what is that, 3. So all real numbers less than or equal to 3. Nine and 10. I'm going to start doing these faster. So our y-intercept is, our vertex is negative 1, negative 2. Negative 1, negative 2. We're going to have an axis of symmetry. X equals negative 1. Vertex is negative 1, negative 2. We're going to plug in a 0 for x. 0 plus 1 is 1. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 minus 2 is negative 4. So 0, negative 4. On the other side, we go right here to negative 2, negative 4. Next, we'll plug in a 1. 1 plus 1 makes 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. So that would be 1, negative 10 way down here and across way down over here, here, and there. So we have a range of all real numbers that are less than or equal to negative 2. 10, our vertex is at 3, negative 6. That means, so vertex 3, negative 6. That means we have an axis of symmetry at x equals 3 is our AOS. Plug in a, because we're subtracting, I'm going to go to the right, so I'm going to sub in a 4. Here, 4 minus 3 makes 1. 1 squared is 1. 1 minus 6 is negative 5. So 4, negative 5. That would mean 2, negative 5. Let's do another one. How about a 5? 5 minus 3 is 2. 2 squared is 4. 4 minus 6 is negative 2. So 5, negative 2. And 1, negative 2. Let's do one more. 6. 6 minus 3 is 3. 3 squared is 9. 9 minus 6 is 3. So 6, 3, and 0, 3. Draw our curved lines. Our range is all the numbers that are bigger than negative 6. Greater than or equal to negative 6. All the y values. Alright. This is in our factored form here, so we have an x-intercept at 5, and we have an x-intercept at 1. So we can just look at this and say, hey, well then I've got a axis of symmetry at x equals, what is that, 3? So then we'll plug in a 3 in here. So what's 3 minus 5? 3 minus 5 makes negative 2, right? And 3 minus 1 makes 2. So we've got 1/2 times -2 times 2. Well, how many negative factors do we have? We've got 1, so we know our answer is going to be negative. And 2 times 2 is 4, and 1/2 of that would be 2, so we're at -4. And that's enough to make our graph. So our axis of symmetry, that's x equals 3. Our vertex is 3, -4. And our range is all real numbers that are greater than or equal to -4. 12, we're crossing at 6, and we're crossing at 2. So that means our axis of symmetry is x equals 4. AOS, x equals 4. So we'll substitute in a 4 here, find our vertex. So 4 minus 6 is -2. 4 minus 2 is 2. And 2 times -2 times 2 makes -8. So we're down here at -8. And that's enough. Vertex is 4, -8. And the range is all real numbers that are greater than or equal to -8. (13) crossing at 7 and crossing at 3. So our axis of symmetry is x equals 5. Plug in a 5. 5 minus 7 is -2. 5 minus 3 is +2. -1 times -2 times +2 makes 4. So we're at 5, 4. Draw our curved lines. Vertex 5, 4. Range, everything below 4 less than or equal to 4. 14. X-intercept, -6. X-intercept, -4. Oh. Axis of symmetry, x equals -5. Plug in a -5 here. -5 plus 6 makes 1. -5 plus 4 makes -1. Times -1, 2 negative factors, that makes positive. So we're at 1. Means we're going down. So our vertex is -5, 1. And our range is all real numbers that are less than or equal to 1. (15) Standard form here. So we need to find our x equals -b over 2a. We need to find our vertex, our x value of our vertex. So b is 4, a is 2. That makes -4 over 4. So that's x equals -1. That's our axis of symmetry. Going to plug in a -1. Y equals 2x squared plus 4x plus 2, and we'll sub in a -1. -1 squared makes 1 times 2. 4 times -1 makes -4 plus 2. 2 minus 4 plus 2 is what? 0. So -1, we're at 0. Did we mess up somewhere? I don't think so. We can look at this and say, hey, our y-intercept's going to be 2. So we're going to be 2. Let's plug in a 1 here. That's our next number. So 1 squared is 1 times 2 makes 2. 4 times 1 makes 4 plus 2. That makes 8. So 1 8 and negative 3 8. Same thing here. X equals negative b over 2a. Negative b, negative 2 over 2a, 1. How many negative factors? I've got 2, so I know I'm positive. 2 over 2 is 1. Axis of symmetry is x equals 1. So let's plug in a 1 and a 1. 1 squared makes 1. Negative 2 times 1 makes negative 2 minus 1. 1 minus 2 minus 1 is what? Negative 2. So negative 2 right here. So let's choose, well, we know our y-intercept is at negative 1, so here and here. Let's choose, how about a 3 next? So we'll plug in a 3 for x. 3 squared is 9. Negative 2 times 3 makes negative 6 minus 1. 9 minus 6 minus 1 is 2. So 3, 2, and negative 1, 2, and that's enough. Same thing here. X equals negative b over 2a. Negative b is, so b is negative 4. A is 1. 2 negatives, 4 over 2. X equals 2. This is our axis of symmetry. Plug in a 2. 2 squared makes 4. Negative 4 times 2 makes negative 8 plus 1. Negative 4 plus 1 is negative 3. Let's plug in another value. How about, well, let's look. Our y-intercept is at 1. So y-intercept is at 1. Y-intercept is at 1. That's enough. And 18. X equals negative b over 2a. Our b value is 2. Our a value is negative 1/2. And 2 negative factors, so I know we're going to be positive. 2, half of 2 is 1. So that makes 2. X equals 2 is our axis of symmetry. Let's plug in a 2. 2 squared is 4. Half of 4 is 2 times negative 1 is negative 2. 2 times 2 makes 4 again. Minus 3, so that's 2 minus 3, which is negative 1. Our y-intercept is negative 3. And that's enough.